Hi, good afternoon, everyone. My name is Sharad Kumar. I'm the field CTO of Data at Qlik. Today, what I'm going to cover is we'll talk about what are some of the key market trends in data that we are seeing, that we are hearing from our customers, and what we are observing in broader market. And I'll talk a little bit about, for each of those trends, what is Qlik doing, right? What are we doing from our product portfolio to support our customers on the journey as they embrace some of these market trends. So just real quick about Qlik. We are a data analytics and AI company. We are global. We have 3,600 plus employees across the world. We are a leader in Gartner Magic Quadrant in 3 different areas. One of the very few vendors who are. Data integration, 7 years, and actually it's 8 years. So the new data Gartner just came out, and we are again a leader in the Magic Quadrant for data integration. Data quality, and 14 years running in analytics and BI. And tens of thousands of customers across the globe use our software for their data and analytic needs. Now what we provide is an end-to-end portfolio of data integration, analytics, and AI. And the entire goal of our portfolio is to enable our customers to get from data to outcome quickly and reliably. So we have 2 parts of our portfolio. Is it the data part of the portfolio, which allows data engineers, data architects to extract data, move it, transform, and get it ready in a business consumption form. And then we have the analytics part of the portfolio, where business-aligned users can then take the business-ready data and then build analytics, build AI applications to generate insights and deliver outcomes. And our software, from an architecture, we are platform independent. We work with all the 3 hyperscalers out there, Databricks, Snowflake, as well as our software works on-premise with platforms like Cloudera. We connect into all different kinds of databases, on-prem and cloud. So we can be deployed in a pure SaaS model as well as a on-prem model, hybrid model. We support different deployment models. So we are cloud first, but not cloud only. So let's talk about some of the, so I've summarized the trends, what we are seeing in the market in 3 major categories. One is, everybody talks about this every day, is increased adoption of AI, which is specifically got a boost with Gen AI. The second trend is around open table-based lakehouses. And I'll dive into each one of these. And the third trend is really treating data as a product to enable better usability and improve consumption by business. How do you package data as a product, bring product thinking to data to make data more consumable? So I'll start with the adoption. So as over the years, kind of the analytics space has been transforming, right? Years back, we first started off with what we call descriptive analytics, which is all about reporting, dashboards, visualizations, to try and understand what's happening in the business, what happened, why it happened. Then we started moving into the world of predictive or machine learning, where we started to build machine learning models, train them on the data so they can help start to make predictions and help us in decisioning, things like next best action or recommendation engines that are out there. And now we're in this world of phase of generative AI, where pre-built models are available to us, which are being trained on a huge corpus of information, can not only answer questions, but also generate new content. Now, if you look at this chart, AI adoption is on the rise. So although AI has been around for a while, it's been hard to do because you require machine learning expertise. You need a lot of data to train models. You need a lot of infrastructure to execute them. So people have used AI, but not every company has really used them in critical aspects of the business. But with generative AI coming in, you can see the curve, the overall adoption of AI is on the rise. Every customer we talk to, they have a mandate to start using and applying generative AI and overall AI technologies in every aspect of the business. And it's a well-known fact that companies who do well from an AI perspective, who are more mature in AI, outperform their peers in all different aspects of the business. Right? So when we talk about data and AI, the two kind of lens we look at. One is applying AI to data itself. So which is to really bring efficiencies and increase productivity into data integration and data management. Example of that would be if I'm doing data quality. Typically, data quality has been a very manually intensive effort, right? Data stewards have to sit in there, understand the data, they build these data quality rules. Now, with AI and Gen AI, it's becoming easier. The machine can recommend data quality rules for you, help you build data quality rules. Same thing, data integration, transformation, detection of PII. So in different aspects of data, we are seeing co-pilots which help with the data integration, data management task and increase productivity. And ultimately where we see this market leading is co-pilots will get evolved into more agents with the agentic architectures which can start to act more autonomously. So think of the world where not only they can recommend data quality rules, they can detect data quality rules and actually fix data quality autonomously because they have learned from the data. So that'll be when we will move to the agents. Right now it's more, we see more co-pilots. Then the second part of it is data for AI. How do you get data into what we call it AI-ready data? So you can feed into either training models or what's called RAG, retrieval augmented generation, where you have pre-built models, or if you're building a chatbots or agents which rely on generative AI and LLM models, how do you feed data to them, right? Because these large language models, they have been trained on public information. They don't understand corporate specific data. So in order for them to answer questions about your business, you have to feed data in a certain way to these models. So you have to get the data ready for AI. So this is another kind of interesting stat. With increased adoption of AI, the focus is also shifting towards you have to get your data right. Because models are becoming commodity, right? I can get models off the shelf. So what differentiates a company is not really the model, but is their data, right? So it's bringing the focus back to the data platform, back to the data foundation. So if you look at some of these numbers out there, since the emergence of generative AI, customers have started to focus more on data management again, in things like supporting their AI initiatives or quality of data, security, privacy of data. Those are becoming more and more important in today's Gen AI type of world, right? So if you look at this, another picture, there's direct correlation between high maturity of data management and deployment of Gen AI solutions. Again, if you compare companies who are early stage AI adopters and mature companies, you can look at along these disciplines of data management and data quality, cataloging, data governance. Mature AI companies have more advanced programs and pay more attention to these disciplines, have more capabilities in their enterprise to support the generative AI. So all this points to the fact that you really cannot do AI properly. You cannot scale your AI initiatives unless you have a robust foundation of data and you handle things like quality, cataloging, metadata, right, in your platform. So we talk about data readiness. So having your data ready for consumption by AI is a very important part. So every customer we talk to now, a lot of the initial, yes, we have the models, but I got to get my data ready, prepare my data to feed into these models. And again, you can see the companies who have their data ready outperform their peers and have more productivity. So as I was talking about earlier, these models that come with generative AI, they call foundation models, they call LLMs, they are pre-trained in a huge corpus of information, but that's publicly available. So you have to bring your data, marry your data with these LLMs so they can answer questions about your business. There are three ways you can do it. Let me start with kind of the middle one. So first approach is build, right? I can build my own model. I can build a custom model using my data, train it, and then it can answer questions about my business. But very few companies are doing it. We already know all the tech giants are all building their models. We see a lot of companies like, for example, Bloomberg, they have built something called Bloomberg GPT because they have an enormous amount of data that they could train. So what we see is really these models being built which are more domain specific, right? So a lot of other companies are building domain specific models. So sometimes we call them SLM, small language model, because so they may not have as many parameters as a Llama or some of these other models, but they're specialized to certain domains, whether it's healthcare. So we see those being built, but fewer companies are doing it, right? Then we see a model of Boost, right? That I can take an off-the-shelf model and I can additional train it on my data to make it specific to my business. So if both of these methods, build and boost, are more complex because, again, they require data science expertise because you got to tweak the model, you got to train it further, you require more GPUs. This is what's driving NVIDIA's stock price up because you got to deploy multiple GPUs, huge number of GPUs, whether you're building a model custom or whether you're boosting a model is more expensive. So we are finding most of our customers in the market using the buy method. That means they would use a model off the shelf, whether they go to Hugging Face, whether they go to your Amazon Bedrock, which you have access to a number of models. So use the models kind of off the shelf. But if you use off the shelf model, you have to feed your data or marry your data with the model at inference time. When somebody asks a question, the model doesn't know about your data, so you have to provide it context at the time of question answer, right? And so that's called RAG. And we're seeing most of our customers who are in Gen AI using RAG. So that means we got to prepare the data, get it ready for RAG type of use cases. So what it looks like, if I blow this up further, a RAG use case, so what does it look like? So let's say we have taken enterprise data, structured, unstructured, and we have prepared it for AI use. So preparing for AI use means that you got to put it into a knowledge base, which is a vector store. So you got to vectorize your data because that's what these machines understand. So once you have done that pre-work, then what happens is when a user has a question to, let's say, a chat application, a customer service agent, when you ask it the question, it searches in your knowledge base in that vector store to get the context. Because again, if I just pass this question here, how is my business doing? How are my sales? This model doesn't know anything about my data. That data is sitting there. So it has to get that subset of context, and along with the question, you pass this context, prompt and enhanced context to the LLM, then it's able to generate an answer for you. Right? So that's how most of these applications are working, RAG enabled agent. I was in the conference listening to different customers. Most of them, that's what they're doing, right? Using the models from Bedrock, right?
Are you seeing your industry doing the vectorizing the data inside their data stores or in a separate system or someplace else? Where, like, logically, where are you seeing?
Yeah, so a lot of technologies are out there. So if you look at Amazon has Elastic, which is their store. We're seeing, I would say, pure play vendors like Pinecone, right, which are vector store databases. We're saying Neo4j, which used to be a graph, but now they support vector. So they're all different. They're open source. They're ones provided by the hyperscalers. There are other vendors who provide. So customers are picking a variety of their own choice.
Yeah, even DBMS relational, like MongoDB.
Now they're all.
Everybody's kind of jumping.
Everybody, yeah, exactly.
Server, the whole thing.
Yeah.
I was wondering where they're going to pick.
Mm-hmm.
Yeah. So just like people pick their relational database, now they have to pick a vector DB of choice.
Except the other DBMSs are adding the vector embeddings into their.
Yeah, so the customers have choice now. Do I pick a database which also comes with a vector, or do I feel more comfortable picking a pure play vector store, which probably may have other better features, and I keep my relational database the same? So I think those are choices customers have to make. But independent of which store, you still got to vectorize the data.
You find when they're making that choice, are they making that choice for performance reasons or familiarity reasons or cost, or is it just a mix?
I think a mix of them, right? So some are to simplify the architecture. Okay, I don't have two separate databases. I think there's a benefit in keeping because you can keep reference to the relational data and to the vector data. Now people are also keeping sometimes data three different more graphs. So you have graph. So this, you guys all heard of graph RAG, right? So now graph, which has additional level of relationship. That's what Neo4j is pushing. That means you need graph. You need that semantic relationship between the data in addition to vectorized representation of data to get more accurate results. So I think in the end, relational representation of data, graph representation of data, vector representation data, and business semantics will all feed into better prompt answer, prompt response.
Are you hearing anything about the concern of additional technical debt by suddenly having to learn a whole, have your development team learn a whole new database or whole new structures and security concerns as well?
Yeah, we definitely do. And that's why if you look at, there are a lot of managed services coming. So for example, I'm not going to talk here, but in our analytic portfolio, we have a product called Qlik Answers. So we are making it simpler. So we are offering that as a service. So we point Qlik Answers to customers' data. So let's say you have a lot of unstructured content product manuals sitting in your SharePoint. You come to Qlik Answers, you configure, you point to your SharePoint repository, and we'll automatically read that, index it, store it in our internal vector store, and just provide you a prompt interface. So think of all of this in a box. So some customers who, like you said, are concerned because they don't want to understand the technology, they don't want to manage these vector databases, they prefer that kind of as a service. All they need to do is point product tool to their, but some other larger companies who are more technical in nature, they want to acquire, they want to make the decision of which vector database they pick. Some are hosting it themselves, some use cloud hosting. So we see a variety of customers, but definitely additional expertise on the database side. I mean, learning new technology of vectorization. That's why even in our product, I'll talk about, we're making it easier for people, so not having to learn as much, right? So now I'll talk about what are we doing. So this is what we're seeing in the market. AI adoption is on the rise. People need to get their data AI ready. They need to vectorize it. They're building these RAG type of applications. So where do we fit in, right? Qlik, where do we support, right? So we're doing multiple things. So if I have to say, kind of in one sentence, what we do, we enable our customers to build a trusted foundation for AI, trusted data foundation for AI. That's our mission, right? From our data perspective for our Qlik Talend Cloud, which is the branding for our data portfolio after the acquisition of Talend, which was a little over a year back. So we've taken the best of Talend and best of heritage Qlik data capabilities and packaged them together into Qlik Talend portfolio. So our mission, how we support AI is we allow people to create AI-ready data sets, and I'll talk a little bit more about these. We enable these RAG type of application development, like agents, and then data quality, right? So because these are our, and I'll talk. So what we have come up with we have come up with 6 principles of AI readiness. Right? So let's talk this up. One, your data needs to be diverse. So if you're building models, you're giving answers, you need to make sure you have diversity of data. Otherwise, you're going to have bias in AI. We all already know that. So that means you want to acquire as broad a data, have breadth of data possible that you can feed to your AI models. Second is timeliness of data. So we are having so many customers reach back out and say, we want to convert all our batch pipelines, which we had built, ETL pipelines in batch mode, daily, weekly, monthly. We want to do more real time because we want to have up-to-date, more recent data available for our AI. So think of a chatbot, right? I built an agent, RAG agent on my website where customers can ask about their policy. They submitted the policy, they come back, ask us, you cannot have the data feeding back into your agent a week later, a month later. Right? So that's a poor experience. So all our customers saying timeliness of data is becoming increasingly important. So people are moving towards more real-time architectures, whether it means that as soon as things change in the database, I need to capture it and flow it forward, or events are happening in my environment. I want to be able to capture it like IoT type events. So events, streaming, real time, timeliness of data is becoming increasingly important in this AI world. Then obviously accuracy of data, we all know, right? Garbage in, garbage out, bad quality of data, bad predictions, right? So well-known fact, to make sure we have clean, good quality, accurate data, important for reliability, effectiveness of your AI, trustworthiness of your AI. Security, right? So again, now we're beginning to feed different types of data to these models, right? Some of it unstructured. What if unstructured data has social security number in there, some corporate sensitive information in there? That could get leaked through these models. So protecting the data, again, very important. We saw the chart, because I think this was number 3 on the chart, security of data, when customers talk about it. So again, all of these are important when you're looking to scale AI. People can experiment in their little silo, but when they look, all these corporates, when they look to say, okay, I'm going to take this AI model, I'm going to deploy it, this thing becomes super, super, super critical. Then discoverability of data, which is make sure data that you create is findable, it has the right business context. Because think of it, you can bring data in a timely manner, you can make it clean, but if the data is not findable for these application developers, for business consumers, is useless, right? So making the data available, findable with the business context is extremely, extremely critical. And we saw a previous chart, like data cataloging was one of the major disciplines for mature AI organizations. And the last principle is data needs to be consumable, right? So if, let's say, I want to train a machine learning algorithm, I got to shape the data in a certain way. If I'm making it ready for AI consumption, we just talked about it, I got to shape the data into a vector form. So I got to make the data consumable. So when we look at holistically, what does it mean to have a data foundation, a trusted data foundation for AI? We look at all these different principles that you need to apply. And these are different, think of it, lens. Every customer we tell you should look at your data landscape through. So not just think, we're putting this into practice, and we've created a framework of what we're calling the Qlik Talend Trust Score for AI, right? Which takes these dimensions and quantifies what's the level of trust, what's the readiness of your data for AI, right? So we have put a framework in place, right, which right now our professional service organization will help clients before it becomes fully productionalized, but will help you create a trust score for it. So think of it now, if I'm an organization, I want to build a chat bot for claims and look at claims data set, and if I can look at its trust score along these dimensions, I can make a decision whether I can use that data as part of my RAG application and put that chat bot on my website or not, because I know the data that's coming is trusted. What's its trust score? Is it timely? Is it accurate? Is it secure? Right? So I can make that decision. So we're creating a framework around calculation of this trust score for AI, which quantifies and gives user confidence in comfort in the readiness of data for AI use.
Is the intention that your customers would ever use that publicly, or is this very much, would they put this on, like, they've got
internal
chatbot, purely internal?
Yeah, because initially we're talking about all internal data for internal use, building AI applications internally.
But they wouldn't say, oh, well, there's a public-facing chatbot and you can trust this because it's trained on this and the trust score is 98.
Yeah. We haven't really guessed, because I think what ultimately they have to do, they have to probably provide a trust score for the entire thing. Because it's not just the data, but then people talk about, okay, what about the algorithm? What about the chatbot itself, right? So I think that's a great idea to have a trust score for the entire thing, right? Because a lot of time, even in the agents that you're talking about, it should be what type of questions you can ask the agent, right? Or what type of answers it should do, right? Certain things could be out of bounds. A lot of people, not just the data, on the AI side, they're putting a lot of guardrails, right? And ultimately, I think together there should be a trustworthiness score of the entire end-to-end cycle. Now, from here, we are guaranteeing from a data perspective, right? But I think that makes sense.
And then are we seeing this is offered up as a data service to the rest of the company to build their own AI tools and implementations?
Yeah, so what will happen is, So we are providing capabilities in our platform for these kinds of things. So diversity of data means we are providing tools and capability in a platform where customers can acquire data from any source they want and bring it together and integrate. Timely manner, we have things like change data capture. So as soon as something changes in a database, if you have SAP, if you have a mainframe, if you have Oracle database, we're able to detect changes and bring them forward. We're able to tap into IoT events or message queues. So we have capabilities in a platform for that. We have data quality, right? So people can build data quality rules, cleansing things, stewardship interfaces. So we have capabilities in a platform along each of these dimensions to have our customers use those capabilities to build out their data foundation and make sure it's AI ready.
And then are you seeing this largely centralized in a central data service, or is it distributed into different business units?
Yeah, good. If you hold that question, my third trend, data as a product, will cover exactly what we're seeing there. Absolutely. That's a great question, yeah. So again, like we said, the two parts of it, right? So even in our platform, we're beginning to provide AI augmentation. So things like pipeline design. So one thing people have to do is build integration logic or data pipeline. Data comes in, land, integration, I have to transform. So in our product, we already launched capabilities where you can type in natural language, English, what you want to do. So you can type, join these two tables around it, and it'll generate code for you, leveraging LLMs. We are going to launch pretty soon, coming out, prompt to data quality rule. Build me a data quality rule to check that this field is alpha numeric of this type, and this field cannot be null when this field is null. It'll build you the code to do those data quality checks. So we're adding AI augmentation into our platform self, right? To make it easier for our customers to use it, right? Bring more productivity into what they do, whether it's data integration, whether it's do data management. And the second part of it, what we were talking about earlier, is helping them create those data-ready data sets, AI-ready data sets, good quality, in RAG form, whatever they need. So both sides, both that picture we looked at data for AI and AI for data, we are addressing both aspects of it from a platform perspective. So if you look at this we talked about this earlier. When we are in the BI business descriptive era, what we had to do to build the pipeline is we had to extract the data from different sources. Typically, we have to transform it and put it into some kind of warehouse model, do all the joins, and then data marts, which are dimensional in nature. So then somebody could build a BI dashboard against that. So you had to build a pipeline to do that. So when we moved to kind of a machine learning type stuff, we had to do that, but we had some additional work to do. So now we had to take the data and we had to create a training data set, an inference data set. You had to build new features on it. You had to build a machine learning model on it. You had to train it. So again, we had to different pipeline. Now the first two, we primarily worked on structured data. That was the world we were living in. But now in this world of generative AI, unstructured data is equally important. 80% of enterprise data is unstructured. And what GenAI is providing is a way to really unlock that unstructured content. So that means I need to now pipeline unstructured data, structured data, and do additional things like we were talking about. We got to chunk it, we got to create embeddings, we got to put them in a vector store, so new capabilities for pipelining. Now, one thing we're doing from Qlik Talend Cloud is we're providing a platform. You can build unified data pipeline because you don't want 3 separate platforms which do these things in different places. Because think of it, if I extract claims data from my mainframe once, I should be able to follow through and build a mart. Somebody can build a BI report on it. But the same claims data, I should be able to take and vectorize it so I can build a chatbot against it and keep all of them fresh as things change. So that's the beauty of what our platform is. We are providing this method for our customers to build what we call unified data pipelines. Whether you are in the world of BI, traditional AI, or Gen AI, we allow you to build these data pipelines using our product.
Curious about the machine learning data pathway. Have you had to build any kind of a feature store as those are developed? Because that's part of that refinement of data and the model together. You have feature tables. I didn't know if that's like
So it goes in a feature. So and more we're seeing, if you look at Snowflake, Databricks tools, both of them within the data platform, now they've converged feature store too. Because what you had to do before is you have your, you're right, you had your data store, and separately you have to store your features. But now what we do, for example, when we do this on Databricks, the features are also stored right in Databricks itself because they have a feature store capability built in, which is more of a transactional type, because that's what you would need at the inference time, because the model needs to act on those features. So yeah, so what we do as part of this is, as you create new features, we put them in the feature store, and more they are converged. Like in Snowflake and Databricks, both of them store data as well as feature, analytic data as well as feature tables. Right? So let's take one more click. What does these pipelines look like, right? So when I'm in the world of BI, typically we see our customers building what we call these medallion architectures, right? You bring the data in from a source, you land it in its raw form in something called a bronze layer, right? And you constantly, through our change data capture, as anything is changing, we're constantly refreshing the bronze layer. So bronze layer is up to date. From there, you promote the data to silver. Now you may, between bronze and silver, you may do is you may cleanse the data, right? You may make it more accurate. You may redact some privacy information. You may tokenize the data if you want, if you didn't do it on the way in. You may start joining the data. And finally, in the gold layer, typically for BI, you do is that's where you create your fact and dimensional models, facts and dimensions, right? Which that's how BI tools like the data, easier to consume. So we allow you to build these pipelines or bronze, silver, gold, medallion architectures to support BI use cases, right? And these data, all these three layers typically live in your lakehouse warehouse. If you're in Snowflake, you're in BigQuery, you're in Databricks, data for bronze, silver, gold would live there. Or in some certain cases, we have seen architectures with the separate data lake and warehouse. So it could happen that your bronze layer may be just, let's say, S3. And your silver and gold may be Snowflake. So it could also vary, or it could lakehouse, could be all three layers in a single platform. So different architecture patterns are there. But typically, we allow our customers to then pick whichever pattern they want and build this medallion architecture. And the pipelines and the transformation that takes the data from bronze to silver to gold for ultimately consumption by BI tools. So when we go to AI ML, now we have the data coming in, similar things. We have data engineering, but we also do feature engineering. So like you were saying, you create new features on the data, you put them in the feature store, you have a training data set and a prediction data set. And then separately, outside of the data platform, you have your ML development. Now, if you're in Databricks, ML development is also provided within the Databricks platform. Within Qlik, in our analytics portfolio, we have a lot of capabilities, auto ML and stuff to create machine learning models against the data, or it could be third party like Data IQ, all different tools are available for that. But what we do from a data perspective is make the data ready. Make sure you have clean data, you can build new features, and all of that is available on the data platform. So as you deploy your models, you can consume. Finally, like we were talking about, for the third type of pattern, which is a generative AI type of pattern, we now not only ingest structured data, but unstructured data. And we put it into, like we were talking about, its final form is a vector store. And these are, like I was talking about, different examples of vector store, right? Even Snowflake and Databricks have their own vector stores as part of their platform. Pinecone, Elastic, Chroma, a whole bunch of them, right, are there. And what we do is within our platform is we take those things, we split it into chunks, we call an LLM to create the embeddings, and then we store it in a vector form. And what's unique, how we do it is because we have this unique capability of change data capture, we're able to keep this vector store fresh all the time. So as you build your agent or chatbot against this vector store to answer questions, you're always answering questions on most recent, timely, up-to-date information. Right.
Is it realistic to do real-time data?
What's that?
Is it realistic to do real-time data currently in this kind of a process? Or does that require too short a timeline to make it all the way through the step?
I think it's, I would say, I call it near real time, right? So as soon as, because typically what we do is a lot of our customers, as soon as say you have Oracle database sitting there, as soon as a transaction commits in Oracle database, we're able to read the change log immediately and follow through. So then it's a matter of your latency. How long will it take? Because it is some latency, because if you have to write to each of the layers and then you call this function, create the embedding, you store it, there is some latency involved in that, right? So it's not really real time like in microsecond, but few seconds.
There are, real-time database or near real-time databases, right? I'm wondering if you can substitute there. Could they be one of the vector stores for this? So,
yeah, so if you look at single store is kind of one of that. So it could be like more of an in-memory store. But the key thing is, you still takes you a little bit of time to create the embeddings, right? You got to take the data.
That's right.
You got to call the LLM as kind of like think of it as a transformation step and create. So you have to do multiple steps. You got to chunk it up. Each chunk you got to create embeddings and then store it in there. Now, right now we're doing it in this fashion. There's no reason why we can't do it if events are coming in, because same capability as event. Each data event comes in, but there is some latency in chunking, embedding, and then storing it into a vector form. Right? So what we're doing is, in a platform to enable this, we are integrating with different types of LLMs and vector stores, right? So our customers, when we provide this platform to our customers, like we were talking about earlier, they'll pick one of these vector stores. So we need to support a wide range of vector stores that they could just plug in. Come into a tool, configure, okay, my vector store, I want to use Elastic. I want to use Neo4j, right? So these are the ones we're supporting. And again, same thing with LLM. To create these embeddings, we are pre-building integration in a platform with different types of LLMs. So as our customer deploy our software, they can pick the LLM that they want. So they would do just like today, they pick their source and target databases to move data around. Okay, I'm taking data from Oracle, I want to take it to Snowflake. They configure these connections. Now what they'll do is configure a connection to their choice of LLM from a drop-down. They'll configure a connection from a drop-down to the vector store, and then the pipeline will run and move the data into that. Right?
Can they bring in an open source LLM or something like that?
I think what we will do is we'll probably provide APIs so they can integrate it. But right now we are supporting kind of standard sets. But once we get to some point in API, so they can plug in whichever model LLM they want. Yeah. And a lot of it, like even on the AWS platform, we go through Bedrock. So a lot of time we can support as new models get released, we should be able to access them pretty easily because all goes to the same kind of interface. The other thing we're also doing is we're adding support for unstructured data. So if you look at traditionally all ETL tools, right, data integration tools were all built for structured data, including our platform. Now, like we said, in this new world, to support generative AI use cases, we got to start supporting unstructured data as well. So first thing we have done is we are adding support in our Talend product in the studio, support for unstructured data. So again, you can build that pipeline and you can say, okay, take this document, let's say it's a PDF document, you can, okay, extract text from it. Then you can chunk it up. Then you can call an LLM to embed. So similar thing for structured data we are doing. We're adding support in Talend Studio for unstructured data as well. So our ultimate goal, like I was saying earlier, is we allow our customers to have one platform for all their needs, pipelining needs. Structured data, unstructured data for BI, AI, Gen AI. So they can build these pipelines.
Maybe a silly question, but it's would the user for the unstructured data and the structured data be exactly the same person? Because obviously you have kind of a history of DBAs for.
Yeah, could be different persona. Yeah, could be different persona. So because these pipelines would differ, right? So yes. So right now what we're doing is kind of like I would say a split experience, right? The structured stuff can be done in a Qlik Talend Cloud. Unstructured support is not there yet, but that's on a roadmap. So ultimately, through our entire platform, we'll be able to support structured, unstructured as well. Right? So now what I'm going to do is I'm going to just play a 2-second video, just take a quick look at the demo of how we build pipelines using our platform.
Here's a Qlik Talend Cloud data pipeline, which solves common requirements for data acquisition, transformation and modeling, and processing of data to a vector store. Now, I have a lot of unstructured content locked away in structured data sources, which makes it difficult for me to get value from them. My hardest challenge is how do I quickly and easily model this data for my RAG use case, and more importantly, keep my vector store up to date to provide correct answers. This is all performed for me by the AI-ready task. In the AI-ready task, you can see I've created a couple of documents using my transformed data. I can easily adjust the document structure, adding subdocuments and enriching the data to ensure I have the appropriate content. The system leverages the data model to automate the initial creation and updates to the document and the document data, and continuously feeds the vector store, which means I can get up-to-date responses for my RAG application. So let's test the pipeline before I turn the output over to my application developers to build the chatbot. We'll ask what type of AI projects the Qlik Data Business Unit is working on, and to provide us more context around the AI-ready data, which, as you can see here, is embedded with CDC capabilities to ensure up-to-date information for accurate AI responses. Qlik Talend Cloud provides that trusted data foundation for AI with pipeline capabilities that span data movement, transformations, quality, and trusted data products. It enables modern architectures for AI, analytics, and data science initiatives, ensuring you can drive better business outcomes and maximize the value of all your data.
So if you look at what it makes it simpler is now users don't need to understand what it means to chunk, what it means to embed. All they do is from the palette where they design the pipeline, they can drag and drop a new task called I want to create AI-ready data. And in that task, they can configure. They would have already configured connections to LLM and vector database. And this is where they can control what part of data they want to vectorize, right? Because you don't want to maybe vectorize everything. You only want to vectorize subset of the data. So they configure and they control that, and then we take it, we convert it into that part of the data into a JSON document, then we chunk it, we create embeddings, and we store it in the vector store. So we have made it very easy. You drag and drop a component, you do some configuration, part of the pipeline, and keep going. And when you run the pipeline, put it into production, then pipeline will keep running and keep your vector store fresh. So now they don't have to specifically make an API call to an LLM. They don't have to understand chunking. They don't have to write code for creating embeddings. They don't have to worry about how to write into a vector store. All that we have codified into our platform. Right? Made it easy for them to build AI-ready data. So that's the kind of the first trend we talked about. Any questions kind of all around where AI is headed and how we are supporting AI?
So back to your data quality score.
Yeah.
Chunking can be a really crucial part of that, depending on the large language model and so forth. Does that data quality score that you've developed, I presume there are several subcomponents to that?
Yeah, those six components.
And so we're at 92%. Is it possible that you could be at, say, 14%? You'd be at 99% on everything else, but 14% on, say, ineffective chunking, or depending on the document.
So if you look at
that's determinable.
So if you look at the trust score we saw, there were 6 dimensions.
Right.
And one of the 6 dimensions, if you remember, was LLM data readiness for consumability.
Okay.
So I think if your chunking was wrong, everything was that score. So the composite score is there, but it also has 6 sub-scores for each dimension. So it could be your data is great quality, but when you made it ready for AI, maybe your chunking was bad, maybe your embedding was bad, and ultimately the vector store that you have, the data is not in the right shape and it's not giving the right answers. So that score could be low. My quality score could be high,
okay,
but that LLM readiness score could be low.
I see.
Same thing, my LLM readiness score could be high, but my quality score could be low because I didn't clean up my data. And yes, I have nice vectorized data, but it's inaccurate data, right? And it's not going to give me accurate answers because my score on the quality dimension is low, right? So it gives you kind of good visual guide for where you need to pay, or it could be, well, this data has everything, but the timeliness score is low. That means it's not been refreshed, let's say, for a month.
Interesting.
So what will happen is everything looks good. My data is great quality. It has great embeddings in it, but timeliness score is 14, which means it's not going to give me great answers on most recent data. So it's a good gauge of which area to focus on based on your score.
Got it.